Okay, so this one is shape area. Below we'll define a n, which is an interesting polygon. Your task is to find the area of the polygon. One sec. Ooh, why is that like that? Find the area of the polygon for a given n. So if n equals 5 or if n equals 4, we need to find the area of that polygon. So, where are we? This one here. When n equals 1, we know that the area is equal to 1. When n equals 2, we know the area is equal to 5. But one key thing to take note is every time when n increases, we already have this number, we already have this area, because that's what 1 is. So when n equals 3, we've already got these squares. Yeah? So technically all we need to do is find out the additional squares on the outside. So in this case it will be the 4 additional. In this case here it will be the 8. And then with this one we've already got all of this here, because that's where n equals 3. So then we just need to find out 4, 8, the additional 12. So a way in how I would sort of work this out, probably the long method, is if we just count the squares on the outside at the moment. So 1, 2, 3. So that's 3 on one side. Now if we count how many squares are on this side, so just recount this one as well, 4, 5, and 6. And if we do that for every single side, so 7, 8, 9, and then 10, 11, and 12. So we know that we have got 12 additional squares. However, what we are doing is by counting these squares twice, we're sort of we're counting an additional 4 squares, and so we're not getting the correct answer, but we need to minus them 4 squares. So if we did 12 minus 4, and that would give us 8. So we've counted 12 squares, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we minus 4, because we've counted these squares on the ends twice, that will give us 8. So 1, 2, 3, 4, 5, 6, 7, 8. If we was to do the same for this one, let's just change the pen. So just count each side. So 1, 2, 3, 4. So when n is equal to 4, we've got 4 additional squares as well. We're counting 4 sides, so we can just do 4 times 4, and that would give us 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which gives us a 16. And then, once again, we're counting these squares twice. So minus the 4, which will give us the 12 additional squares. So 16. Let's just change. So that is when n is equal to 3. 16 minus 4, which gives us the 12. And this is for when n is equal to 4. But what we actually did to get this number here, 16, was we did, just put this in brackets, n times 4. And that gave us a 16. Same with this one here. We did n, because n was 3, times 4, which gave us the 12 number. 12 minus 4. So we do the same on this one. I'm just trying to visualize it. N was equal to 4, so that's 4 times 4, so that gives us a 16. Minus the 4, which then gives us the 12. So that's great. We've now found out the area, well, we found out the additional squares. So now we need to add the area from the previous n. So when n is equal to 1, great. We move on to this one here. We know that the area is 1. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 times 4 is 8. And then we're counting these, goodness me, these circles are horrible. We're counting these ones twice. So 8 minus the 4 is equal to 4. I don't know why I've gone to that page. So 8 minus the 4 is equal to the 4, which works, plus this one here. So that would be 4 plus 1 is equal to 5. Do the same for here, so we know that this area here is 5. So we've already worked out this, which was equal to, I think it was 8. And then 8 plus the area, which we've just worked out on this one here, which gives us 13. And then the same with the second one, 13, then plus the 12. So if we write all this out into the actual function, we will always know that the area is going to equal 1. Because when n is equal to 1, the area is always equal to 1. And now we need to loop through n, because every time, say for instance, n is equal to 3, we need to add this area onto sort of this little logic that we've got here. So if we do a for loop and say we let I is equal to 1, and if we do I is less than or equal to n, and then we want to I++, because we want to go through I each time, adding the area onto the area each time. And then if we write this little logic here, so we do const, say x is equal to 4 times, and then this time we can't do 4 times n. Put this in brackets. We can't do 4 times n, because that means every time we loop through I, which, like, say n is equal to 4, then every single time we do the loop 4 times, we'll be doing 4 times 4, which won't work. But we want to do, first of all, 4 times 1, and then 4 times 2, and then add in the area each time, 4 times 3, slowly building ourselves up to then 4 times 4 to get the additional squares, then adding these squares onto the additional squares. So if we do 4 times n minus the 4, and now we know that the area is equal to the area plus x. And then a short way of writing that is just area plus x. So for instance, the area is 1 at the moment. We're looping through it because n is equal to 1. We're looping through n once. So if we go to the logic, x is equal to 4 times I, which is 1. That is equal to 4. 4 minus 4 is 0. And the area is already equal to 1, so that's 1 plus 0 is 1, which is our area. If we say we do it for n equals 3, so we loop through it once, which we've already just done, so we know the area is 1 for n is equal to 1. Now when n is equal to 2, we do x is equal to 4 times 2 this time, which is 8, minus the 4, which is 4, and now 4, because x is equal to 4, so we do 4 plus 1, which gives us 5, which is the number we're looking for. And now n is equal to 3. Loop through it again. X is equal to 4 times 3, which is 12, minus the 4, which is 8, and that's how many additional squares we've got. And then the area at that time is equal to 5, because we've already added the n is equal to 1, n is like the I1 and then I2. We're accumulating it. So we know that the area at that time is equal to 5, then 5 plus x, which is 8, gives us 12. No, it gives us 13, which is what the area is equal to. So we jump out of that for loop, and then if we just return the area, it should submit and correct. Probably is a more efficient way of doing this. Like if we look at the solution here, I'm not understanding this, so I'm not going to try and explain what's happening when I don't get that just yet. But for a sort of visual way of looking at it with the shape, I think this is a good way of explaining it.